Welcome to Everyday Mathematics. Today we would like to take a foray into the 2024 University of Florida Integration B qualifying round. And there were about 30 problems. We're going to look at the first batch of 10 problems today, and we will call this part one of that series. So we have problem 1, problem 2, problem 3, problem 4, problem 5, 6, 7, 8, 9, and 10. So these are very interesting problems. We will quickly go through them. Where need be, we'll expound on some of the concepts that undergird some of the solutions that we'll be providing. If you haven't subscribed to our channel, and if this is your first time, and or you're returning for the second time, and you find this channel worthy of your attention, we do encourage you to consider subscribing to our channel. We also encourage you to like if you see what we're doing to be interesting. Please don't hesitate to leave a like, and if you can, please share. So without much ado, we're moving forward to the solution section of this problem. Problem number 1, which is the product of constant u, constant m, and the definite integral from x equals to 0 to x equals to 1 of a constant s. So this is a very easy problem. I think this was just to get everyone excited. What we can do is we can pull the constant s out. So we have ums, the definite integral from x equals to 0 to x equals to 1 of 1. Which is so ums 1 minus 0, so ums is our answer. So as simple as that. Then let's go to problem number 2. Number 2, which is the indefinite integral of the square of x minus 1 over x, which is the same as the indefinite integral of x squared minus 2 times x times 1 over x plus 1 over x squared. So that and that would cancel, so we have the indefinite integral of x squared minus 2 plus 1 over x squared. So this is same as x cubed over 3 minus 2x minus 1 over x plus the integration constant c. And that is our answer. So we're going forward to problem number 3. Problem number 3, the indefinite integral of cotangent of x minus 1 over cotangent of x, which is just the same as 1 over cotangent of x, the same as tangent of x. So we have integral of cotangent of x minus tangent of x. And we can express this as obviously cosine of x over sine of x minus sine of x over cosine of x. Now this part here is the same as the derivative of cosine of x, and this part here is the same as the derivative of sine of x. So we'd express this as the derivative of integral of derivative of sine of x over sine of x plus the derivative of cosine of x over cosine of x. And we know we just have a sidebar here. If you have an integral of a derivative of a function fx over the same function f(x), we get this to be the natural logarithm of f of x plus the integration constant c. So using these, we come here and say, okay, so we have log of sine of x plus log of cosine of x plus the integration constant. And that is our answer. Okay, some folks like putting an absolute value around the the functions within the log function, but here we'll choose to keep it, our functions the same. So we have natural logarithm of sine of x plus natural logarithm of cosine of x plus the integration constant. So let's continue to problem number 4. Problem number 4, which is the indefinite integral of e to the power 5x times sine of 2x. What we can do with this problem is we could first of all equate it to I, right? And there's a reason, because we're going to have a cyclic operation here. So I is the same as the indefinite integral of the derivative e to the power 5x is the same as the derivative of 1 over 5 e to the power 5x times sine of 2x. We can use integration by parts. That tells us that if we have a product of a function v and a derivative of a function capital U, if you integrate that, we have u v minus the integral of u times the derivative of function v. So with that in mind, if we take this to be v and this to be u, then our I is the same as 1 over uv is this minus the integral of 1 over 5 x times the derivative of sine of 2x, right? So this is the same as a fifth e to the power 5x sine 2x minus the integral of a fifth e to the power 5x times the derivative of 2 cosine 2x. So we can pull this constant out so that we have now 1 over 5 to the power 5x sine 2x minus right? And then we can re-express this as, again, the derivative so this is the derivative of 1 over 5 e to the power 5x cosine of 2x. That means that we've come to a point where we have I is the same as a fifth e to the power 5x sine 2x minus 2 over 5 the integral of 1 over 5 e to the power 5x cosine of 2x. So using integration by parts again, we have uv is right minus integral of 1 over 5 e to the power 5x, the derivative of cosine of 2x, right? So this means that we have 1 over 5 e to the power 5x sine of 2x And then we have 2 over 25 e to the power 5x cosine of 2x. And then this and that interact, so we have a plus. We can bring this constant now, so we have 2 over 5 e to the power 5x times negative 2 sine 2x. So this is 1 over 5 e to the power 5x sine of 2x minus 2 over 25 e to the power 5x cosine. Sorry, we had to bring this 25 here, so, and then now we can pull this negative 2 out, so we have negative 4 over 25 integral of e to the power 5x sine of 2x. And we see that this is the same as I as well. So we have a situation where we have I on the left hand side, 1 over 5 e to the power 5x sine of 2x minus 2 over 25 e to the power 5x cosine of 2x rather, minus 4 over 25i rather. So we can add both sides with 4 over 25i, so we have 1 plus 4 over 25i is equals to 1 over 5 e sine of 2x minus 2 over 25 e to the power 5x cosine of 2x. So when you add these guys together, we get 29 over 25. So we have 29 over 25i sine of 2x minus, so we have 4, actually 2 over 25 e to the power 5x cosine of 2x. So if we divide both sides by 29 over 5, we find that we have I is equals to 1 over 29, open bracket, we have 5 e to the power 5x sine of 2x minus 2 e to the power 5x cosine 2x. So therefore it's safe to say that e to the power 5x sine of 2x integrated is 1 over 29 times 5 to the power 5x sine 2x minus 2 e to the power 5x times cosine of 2x plus the integration constant. You don't want to forget that. So that's problem number 4 for us. Now we'll move forward to problem number 5. So problem number 5, which is the indefinite integral of the square of 1 minus second of x. So we can expand this problem to the indefinite integral of 1 minus 2 sec of x plus and it's very easy to see that this is the same as x minus 2 natural logarithm of second of x plus tangent of x. So that's the when you integrate second of x, you get this. plus, and the integral of sec squared x is the same as tangent of x, and plus integration constant c. Sometimes, one may ask, how do we come to log of secant of x, tangent of x? So let me probably spend some time there. So this is, by the way, the integral of secant of x. This is the same as the integral of 1 over cosine of x, right? And so it's the same as the integral of 1 over cosine squared x over 2 minus sine squared x over 2. We could say let t be equal to tangent of x over 2 such that dt dx is equal to a half sec squared x over 2, and that means that we have 2 dt over sec squared of to dx. This is the same as tan squared x over 2 plus 1, which is the same as 1 plus t squared is equals to dx. So this is important for us. Now, it's also very vital, since we have our integral to be that, and we say that t is equals to tangent of x over 2. If we draw a triangle here, and the best angle is x over 2, since tangent is opposite over adjacent, t over 1, so this is t over 1, and so the hypotenuse is square root of 1 plus t squared, such that cosine squared x over 2 is equals to this over this, which is 1 over square root of 1 plus t squared, all squared, which is 1 over 1 plus t squared. And sine squared x over 2 is the same as t squared over 1 plus t squared. So with that in mind, we have now integral as 1 over 1 plus t squared minus t squared over 1 plus t squared times 2 dt over 1 plus t squared. We see this and that would cancel, so we have twice the integral of 1 over 1 minus t squared, and we can use the difference of 2. We have 1 over t, 1 plus t, and so partial fractions, we come with 1 minus t plus 1 over 1 plus t. So since we have this, therefore negative log 1 over t plus natural logarithm of 1 plus t plus c, which is using rules of log, where we have, if there's a minus, we're dividing whatever is under the log function, and since t was same as tangent of x over 2, so we have tangent of x over 2 over 1 minus tangent of x over 2 plus c. So this is the same as log of cosine of x over 2 plus sine of x over 2 over cosine of x over 2 minus sine x over 2. Since we have log, and I'm going to write it in a funny way for now. Plus c, if we multiply both the numerator and denominator with cosine x over 2 plus sine x over 2, it becomes log of cosine squared x over 2 plus sine squared x over 2 plus 2 sine x over 2 cosine of x over 2 over cosine squared x over 2 minus sine squared x over 2 plus c. The denominator is the same as cosine of x. The numerator, this part here is the same as 1, so we have 1 plus this part is the same as sine x over cosine of x. So, which is the same as natural logarithm of, if we separate things here, we have secant of x plus tangent of x plus c. So we have proven that. Okay? And so the answer from there forward should be straightforward. So we're going to problem number 6. Problem number 6, the indefinite integral of x squared times e to the power negative x. So we can definitely express this as the indefinite integral of the derivative of negative of e to the negative x times x squared. And then we can go back to our old integration by parts, integral of function v times the derivative of function u. We have uv minus u dv. So we've looked at this in a previous problem, so we won't expand on that any much. But uv would be negative x squared, negative x minus negative e to the x times the derivative of x squared. So this is negative x squared e to the negative x. This negative and this negative, we have a plus integral e x times 2x. So we can pull the constant out. And then we repeat the same process where we have the derivative of negative with x. So we have x squared e x minus 2. We have negative x e to the x. And then we come down to plus, because we have a minus here, integral of e to the x, the derivative of x. And so this is negative x squared e to the x minus, sorry, there was a plus here, so this is a minus 2x e to the negative x plus 2 e to the negative x. So we've come to it becomes x e x to x e x minus 2x plus the integration constant. Therefore, integral of x squared times e to the negative x is the same as c. And that is our answer. Okay, let's move on to problem number 7. On to problem number 7, which is indefinite integral of cosine of x minus 3 over sine of x minus 3x. So this is an interesting problem. It's just very easy to say, okay, the numerator looks like the derivative of the denominator. Okay. And since we know that if you have the derivative of f of x over f of x and you integrate that, the same as natural logarithm of f of x plus c. So using this expression, our answer becomes natural logarithm of sine of x minus 3x plus the integration constant. And that is it. So let's move on to problem number 8, which is, I think, one of the interesting ones. Let's see how to solve it. So number 8 is the indefinite integral of x and the square root of x. Nested in that square root, we have square root of x times square root of x, and so on and so on and so on. So what we can do here is we can say let y be equal to the x square root of x square root of x square root of x, and so on, such that when you divide both sides by x, we have the same thing. But now if we square it, we get this is the same as y. So what this tells us is that y squared over x squared is the same as y. So y squared is equals to x squared y, meaning that y squared minus x squared y is equals to 0. We can factor in y out. We have y minus x squared is equals to 0. So we ignore the non-trivial the trivial term, which is y is equals to 0, and we go with the non-trivial one, which is y is equals to x squared. So that means that our integral is the same as that, which is equals to a third integration constant. So that is the answer for problem number 8. Let's then move to problem number 9. 9 looks a little bit intimidating, but it's actually a very easy problem. What we're going to do is, the problem itself is the definite integral from x equals to 8 to x equals 63 of 1 over the square root of 1 plus the square root of 1 plus x. So as is the norm, at least how I handle things is I begin substituting off the complex part. So the first thing I'll do is I'll say let u be equal to the square root of 1 plus x, because that looks a little bit clunky. And that means that u squared is equals to 1 plus x, meaning that 2u du dx equals to 1, implying that 2u du can be used to substitute for dx. Right? And then when x equals to 8 on the lower limit, u is equals to square root of 9, which is 3. When x equals to 63, u is equals to square root of 64, which is 8. So what we have here is in the x domain, if we have that, and we convert to the u domain, uh, 3 to 8, 1 over square root of 1 plus u to u du. We can pull 2 out, so we have 8 u over the square root of 1 plus u. So since our problem has come to the next thing is to try and substitute off for again a complex part. So we say let y be equal to the square root of 1 plus u, which means that y squared is equal to 1 plus u, and so 2y dy du is equals to 1, meaning that 2y dy is equals to du, or can be used to substitute for du. And then when u equals to 3, y is equals to square root of 4, which is 2. When u equals to 8, y equals to square root of 9, which is 3. So in other words, our problem in the u domain, which is twice the integral from u equals to 3 to u equals to 8 of the square root of 1 plus u, is the same as twice the integral from 2 to 3. And since we see here, this means that u is equals to y squared minus 1. So we have y squared minus 1 over y dy. So we see this y and this y goes, and this constant comes out. So we have 4. The definite integral from y equals to 2 to 3 of y squared minus 1. So now that we have 2 to 3 y squared minus 1, this becomes 4 y cubed over 3 minus y. Okay, so which is 4 3 cubed over 3 minus 3 minus 2 cubed over 3 minus 2, which is 4. This is 9 minus 3, which is 6 minus, and then we have 8 over 3 minus 2, which is 8 minus 6. So we have 4, 6 minus 2 over 3, which is 4, 16 over 3, which is 64 over 3. And this is the final answer. Okay, so next we go to problem number 10, and then we close this series. Number 10, which is indefinite integral of 1 over e to the x minus 1. The easiest thing here for us to do is we write the integral as it is, and then we divide by e to the x, both the numerator and denominator. So we have e to the power negative x over 1 minus e to the power negative x. Now clearly we see that the numerator there is the same as the derivative of 1 minus e to the power negative x, or the derivative of the denominator. And as we had seen previously, that if you have an integral, the derivative of a function of fx over fx, if you integrate that, the same as log of fx plus c. So this means that our problem here becomes natural logarithm of 1 minus e to the power negative x plus the integration constant. And that is our answer, ladies and gentlemen. So it's been an absolute pleasure going through these first 10 problems of the University of Florida Integration B qualifying round 2024. If you do have any question, please don't hesitate to reach to us via the comment section. If you do have suggestions and alternative ways to solve some of these problems, we do welcome your suggestions. We're here to learn and we're here to share knowledge. So again, if you haven't subscribed to our channel, we do encourage you to consider subscribing to our channel. If you like what you see here, please don't hesitate or don't live without leaving a like. Until next time, have a fantastic day ahead. Bye bye.